Hi, welcome to this video looking at perpendicular gradients. What we want to learn from this video is be able to use gradients to prove that two lines are perpendicular and also find the gradient of the perpendicular line having calculated your original gradient. Okay, so looking at this here, if we want to look at perpendicular lines, firstly we're interested in the gradient. Okay, so the gradient of OC here, we know is the vertical over the horizontal, so it's just going to be O over A here. Now, what we want is we want to look at the gradient and compare that of a line that's perpendicular to that. So what I'm going to do is I'm going to use this line here, okay, which is just using theta as well there. Okay, now because this angle in here makes this theta up to 90, it also has to make this theta up to 90. So in there, we have to have a right angle. Okay, so the lines here, let's call that B up here. The line OC and OB, they have to be perpendicular. Okay, so these two gradients are perpendicular. Now what I'm also going to do, because that's exactly the same triangle, it's exactly the same length of line I've used, then this one here also has to be the opposite. Okay, it's got to be exactly the opposite, and same here, this length here has to be the adjacent, which means I can now find the gradient of that line OB. Now I know it has to be a negative gradient. The vertical distance is the adjacent, and the horizontal distance there is the opposite. So these two gradients here are perpendicular. Now the first thing I want you to notice is, if they're perpendicular, well, this fraction here is just exactly the same as that fraction there, but turned upside down, and the sign's different. So if we have two perpendicular gradients, in reality all that's happening is we're flipping the fraction and changing the sign. The other thing though, which is probably not as easy to see, is if we multiply those two gradients together, we're going to do O over A multiplied by negative multiplied by negative A over O, which is going to give us a negative fraction with OA over OA. Because it's OA over A, we know that's just going to be negative 1. Okay, now in practice, the vast majority of examples we're going to use this with is if we have a gradient and we want to find the perpendicular gradient, we flip it upside down and change the sign. But in reality, if we have perpendicular gradients, the two gradients have to multiply to give negative 1. That's a kind of more formalized rule around it. Now, there's a note, very quick note, followed by two examples. Pause it if you want to copy. Okay, and here's an example. So if S is a point 37t is that point, find the gradient of a line perpendicular to ST. Now, if we want the gradient of the line perpendicular, all we need is the gradient of the line ST. So let's find that gradient there, ST. That's going to be 4 subtract 7 over negative 5 subtract 3, which is going to be negative 3 over negative 8. So let's just call that a 3/8. So that's what it is. Okay, now if you know your gradient is 3 over 8, then the gradient of the perpendicular, which I'm just going to use this wee sign here for, is that fraction flipped. So 8 over 3 now, but sign change, so it's negative 8 over 3. And what you should be writing in here is a little explanation. And this is just one of those annoying things you have to write. Since 3/8 multiplied by negative 8/3, and I'm running out of room, sorry, but this is equal to negative, I'm going to put it down here, sorry, equals negative 1. Okay, now that's what you should be using as your explanation anytime you do this. Take your two values you've done and then show that it multiplies, give negative 1. Okay, and that's your work. Okay, that's all you have to do. Find your gradient, flip it, change the sign, put in a little explanation. Okay, here, example 2, triangle PQR has vertices, blah, 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 blah. Show that triangle PQR is right angled at Q. Now, if we want to show that it's right angled at Q, we need to show that the gradient of PQ multiplied by the gradient of QR is equal to negative 1. Okay, that's what we need to show. because we know for perpendicular gradients, they multiply to give -1. So the gradient of PQ, 11 subtract 6 over 5 subtract 2, that's 5/3. The gradient of QR is 14 subtract 11 over 0 subtract 5, which is -3/5. And lo and behold, 5/3 multiplied by -3/5 is equal to -1. Therefore, PQ is perpendicular to QR. Okay, notice what I've done there. Now that's just my working. I've found the gradients, I've told them why I'm finding the gradients, and then I made a statement after it. Okay, now from our learning intentions, be able to prove that two lines are perpendicular using gradients. That's what we've done in example 2, and be able to find a perpendicular gradient is what we did in example 1. Okay, any issues, ask your teacher. Thank you.